I'm Anisha, and when I'm not watching TV, I work as a React Native developer advocate at Amazon. I work on improving the developer experience for our devices like Fire Tablet and TV.
And I'm Łukasz. I work at Stack as a software developer and a team leader for React Native TV project.
Together, we've done about 8 talks, 5 podcasts, a couple of articles, and a bunch of videos on React Native for TV. We also wrote a book about how you can master using React Native for TV, which Łukasz will be signing copies of later, right?
Sure. I have a bunch of them in my hotel room since this is such a hot topic.
Awkward.
So it wouldn't be an understatement to say that we've been pushing you to develop for TVs so hard.
But don't worry, this is not a talk about React Native for TV.
As React Native developers, we know that our ecosystem is evolving rapidly. We are no longer building for just mobile. We are using it to build for VR and desktop and web, and then TV.
When we first started building for TV, we thought, OK, we're experienced React Native developers, right? TV is just another platform. We'll make some layout adjustments for a bigger screen. It's going to be fine.
It wasn't fine at all. Because when you're building for TV, you have to handle 6 different platforms, 4 different device categories, with models ranging from brand new 4K boxes to decade-old TV sticks with Android 5 on them. On top of that, user expectation about performance is really high. They don't care that they bought this TV 10 years ago and it was cheap back then. They just want to watch Black Mirror episode without feeling like they are in a Black Mirror episode. So our naive assumption of this building just another platform turned out into most demanding, fragmented, and complex task that we've ever encountered.
Because in TV, nothing is optional. You must think about performance early. You must plan your state management carefully. You must think about accessibility, tooling, CI, and your code structure at scale. Because if you don't, your app breaks silently on one obscure device in one country.
So here's the thing. We realized that solving problems for TVs made our overall approachment to development better.
So whether you're working on a mobile banking app, a large-scale web platform, or a multi-platform product, the insights from TV will help you architect, optimize, and scale for multi-platform applications that perform consistently regardless of the device that they're running on.
So we're going to walk you through a few things that we learned from building scalable TV products, and we'll give you lessons that you can apply tomorrow, no matter what you're building.
So the first thing that TV made me rethink was how should we choose libraries? Is it based on my team preference? Is it based on #GitHub stars? Or did we even need it in the first place? TV development forced us to confront this because I realized that these choices can have uncalculated consequences across the hardware spectrum that we have to deal with. The gap between a high-end device like Apple TV and a low-cost one like a Fire Stick means that every library package choice is amplified. A library adding just 100 kilobytes to your bundle might seem negligible on mobile, but with 1 gig of RAM, your library choices impact what users perceive as speed. Because your JavaScript bundle size directly impacts your app's time to activity, runtime memory consumption, and CPU usage during execution. Let's look at a commonly suggested swap, Moment.js for date-fns. And I chose this not just because of these headlines, because it's likely that their maintainers aren't in the audience for once. So using bundlephobia, which helps you quickly check the cost of adding an NPM package to your bundle size, date-fns was 77 kilobytes, and Moment.js was nearly 300 kilobytes. But when I analyzed the actual JS bundle size using Export Atlas, something surprising happened. Date.fns showed up as the larger package. Why? Date.fns is architected as 300+ small utility files, each one doing one thing. And now that's great if your bundler is configured for tree shaking. It can strip out all that unused code and only include what functions you called. But Metro isn't configured for tree shaking by default. And while it is currently experimental in Expo, if you aren't using tree shaking or your import patterns are off, you end up bundling all those 300 files, whether you use them or not. So now using our FireOS performance testing tool, let's see what those extra kilobytes did on my Fire TV. They added almost 600 milliseconds to our time to interaction from cold start. Now, this is just an example, but this could be any library. So here's the thing. A library might look super helpful, but it comes at a cost. And on TV, those costs add up. So how can we weigh up the costs? First, as we saw, make sure you consider the actual bundle size on your target platforms. Then, measure the performance cost. And finally, consider for platform quirks. Flash List works on mobile, but on TV, it might not have the functionality to handle all the dynamic content, focusable content that we have to deal with. So, lesson number 1, be deliberate and critical with your library choices. So I mentioned that one of the considerations we want to make is based on performance.
Yeah, so let's talk about that. Because something breaks at scale, it's usually performance. Working in multi-platform environment means that we are no longer targeting.
Sorry.
That's me. We're no longer targeting just 2 or 3 platforms. We're targeting a mess of platforms, including things like old TV boxes from years ago, web-based OSs with custom Chromium in it, and a lot of these devices are slow. They're really slow. But people still use them, and we still want those people to have a good experience. So here's the problem. We have a shared code base across all of those devices. So if we introduce a change in our code base, like a library change, one device might break, and you won't notice that if you not measure on that particular device separately. And let's face it, you're not going to test on each and every device for performance. So you need a plan. Let's select a set of representative devices for each platform, the low-end ones, and to give ourselves a meaningful spread of targets. Then, before too many sprints pass, let's agree on some KPIs for our product. KPIs like app cold start or time to interactive, or some more complicated user journeys, like when I start the app, I go through some 2 screens, and then I play video. This sounds like a good metric for a video app. Then, document target values for each device and share them with the team so that everyone knows what good looks like. And then you need to measure, and you need to measure often.
Wait, we're not done yet. Where are you going?
I'm going for a coffee.
Why?
Well, this will take a while. So I have 2 QAs measuring performance on, 10 different devices. Might as well just watch Black Mirror or something?
Come back. Finish your talk, Łukasz.
Okay. So I'm going to skip the animation, and definitely, you don't want to be measuring by hand, because it's even impossible, right? Have you ever tried to measure the TTI on the screen manually with the stopwatch?
I'm clumsy. My reflex are definitely not fast enough for those sub-second.
Yeah. So you need to automate it. So those are the kind of tools that you would use in your everyday life, in your pipeline, to plug into and to measure things. And then just embed performance metrics in your code, run them automatically on your CI, and collect the metrics. So the actual implementation of this doesn't matter as much as the overall strategy and process, which is run the standardized performance tests automatically on representative devices. This is as simple as that. Now, the thing about performance is great to measure it, but it's going to be even better if you don't break your app in the first place.
And we can do that with our next learning, testing. As Łukasz highlighted, when it comes to TV, you're targeting multiple platforms. And often you have different versions of the same hardware, like a Fire TV versus a Fire TV stick. And in this world, you can't afford to write code and just hope it works well everywhere. A single code change might work perfectly on one platform, but that doesn't guarantee success on everywhere else. The same code can have different results. Manual QA is not an option, because each code change requires validating 6 different test loops. And it's not just that my London apartment can't handle 3 TVs. I would love 3 TVs. You're dealing with exponential complexity as issues compound across platforms. And this is why manual QA simply collapses under its own weight. So we have no choice but to turn to test-driven development. But now we have another problem. On TV, our TBD loop explodes into 6 parallel loops. And this isn't just TV. This is whether you're targeting 1 or more platforms. one for each platform, one test loop, and each with its own quirks. And suddenly, maintaining tests becomes just as painful as maintaining the code that we wrote ourselves. So what do? It's clear that we need tests that are stable, maintainable, and extendable. And how can we do that? Let's take an example scenario. When I click on a specific D-pad button, I want an overlay to appear. The start and end screens are the same on each platform. It doesn't matter whether I'm using tvOS or Android TV. But when I have different remotes and each one has a different response, I need to make sure that I don't write 6 different tests. I want to test to be the same, so I want to abstract away that platform-specific functionality, which is, in this case, the D-pad button. So let's look at our test. The button's going, sorry. So let's look at our test. When we write our range, it's going to be the same. We set up the platform. Then act is where we can abstract away that platform-specific functionality. Assert is going to stay the same. Something happens on the screen, right? So even writing this one test scenario with an abstracting call for platform-specific functionality, we can see how we can extend this. And we ensure that our integration tests are unified and extendable in a maintainable way. So what's the lesson here? By designing your test strategy to be extendable, you can write tests once and test them everywhere. So this is how we extend our testing strategy locally. But how does this scale to our whole pipeline?
On the pipeline side, every step multiplies for each target. So if you think about the CI/CD setup in your project, it typically looks something like this. So this is a simple build and test workflow. You install the dependencies, you run the validation layer, build native binaries for iOS, Android, then you bundle JS bundle for iOS, Android, and web, and then you run end-to-end tests. This is simple and typical, and it usually works. It works for many projects. This is just fine. But remember that in TV land, we have this pipeline multiplied by our 6 platform and 10 different targets. The fine will not be enough here. So this is where we start, again, typical build and test pipeline. But when you break down the timing, you will see that we spend 20 minutes for each end-to-end for each platform, and then 30-something minutes for native builds for platforms. So let's just optimize it. So let's build on that testing section that you just explained. You'd be surprised how many of the slow device-based tests from end-to-end section we can rewrite to test with React Native testing library as integration test using that abstraction techniques that you showed. So that goes there. This lets us run 80% of the same logic much faster, earlier, and without ever booting a full emulator or device. We want to fail fast, and we want to fail cheap. This is a simple move. We're adding 15 minutes to that validate step, but we are cutting end-to-end times in half. Now, let's look at caching. By reusing cached node modules, Gradle files, pod dependencies, we're able to reduce the install step by about 1 minute and make each native builds 3 minutes faster. This might not seem as a big saving, but those small savings add up when you have 10 different targets. Now, this is the big one. So caching native builds are our most expensive step right now. It takes about 30 minutes to build the app. Using the technique called fingerprinting, we can create a unique hash or fingerprint that uniquely describe our native bundle for iOS and Android. And then we know that a project needs to be rebuilt only when that fingerprint has changed. In React Native projects, this happens rarely. So most of the changes are on JS layer, and we can opt out of building native binaries completely, most of the time. So to use fingerprinting, you can either use build cache provider that comes with Expo, or if you're using React Native Community CLI right now, you can migrate to our new React Native Enterprise framework, which also supports remote caching with the same fingerprinting technique. There's still more to do, though. When you create small PRs, like changing tvOS-specific dependency, like a native library, You don't want to be building and testing every other platform. That's why we use div-based triggers, where we build only the platform that has changed. If your PR touches only Apple TV dependency, you don't spin up builds for Android TV or WebOS. This technique can give you massive time savings.
Does that mean my lunch break is shorter?
It will free up your time to do the most favorite thing of yours, which is TV development.
Love it.
OK, so that's the lesson. When you're small, your CI/CD pipeline can look fine. Builds might be a little slow, but hey, they work. But once you scale, small inefficiencies become big bottlenecks. So don't wait for scale to hit you. Build your CI/CD like you're already big.
Now, one unique thing that TV taught us was that you have to shift your mindset and think in D-pad. And I know we promised this isn't a TV talk, but we have a point. On mobile, users interact directly with the screen, tapping any element that they want. It's intuitive and spatially unrestricted. Take this layout with a side menu and 6 content cards. On mobile, you can just tap whichever one you want to catch your interest. But TV interfaces demand a completely different mental model. Viewers navigate using the D-pad on the remote, up, down, left, right. This constraint forces us to create clear, structured, and predictable navigation paths. Let's look at our example layout. When a viewer is focused on the menu and clicks right, which card should they receive focus? When they're on card 4 and they click left, should they navigate back to the menu, or should they go to card 3? Building for the user flow doesn't just enhance the user experience, it improves accessibility. When you deliberately map out focus paths, users can move through your interface without getting lost. And this matters because people aren't just using touchscreen anymore. They're using their mouse. They're using keyboards, screen readers, assistive technology that behaves just like a D-pad. And honestly, if you've never turned on accessibility mode on your phone, do it. You'll know exactly how your grandmother feels when she's trying to use a phone. That's why directional design and clear focus paths aren't just optional, no matter what you're building. They ensure that everyone can use your app. So, build for flow, not just for layout. With directional navigation in mind, we can create those clear, predictable, accessible interfaces.
OK, so while D-pad is our friend,
in some cases,
in many other, it is not. Let me show you why. So when you're developing for mobile, you usually uninstall and install your app several times a day, and then maybe you will try to wipe out the data storage or whatever. And it takes, I don't know, like a few taps to do that. You don't even register it as friction. It doesn't take that much time. But on TV, it's a whole different game. You're navigating with clunky, D-pad-based UI, typing with on-screen keyboard, and it takes a lot of time. And it's just like so annoying. So after the third time today, when you try to do that, you're ready to throw out that remote out the window. And that's the core issue. Developer friction kills focus. It doesn't just slow you down. Instead of getting into flow and shipping your features, you're fighting with basic tasks. So what's the answer? Again, it's automate everything that breaks flow. The more you can script, the more your brain can focus on solving real problems, not fighting with your setup. Do you know what this script does? It helps to keep my sanity when I try to log into my TV app the third time today. It does it in 2 seconds instead of me spending 2 minutes on it. So whatever your use case, look for friction in your process and smooth it out. For us, it was this login, reinstall loops. So we wrote scripts to handle all of that with single terminal command. You want to make sure that your workflow supports your growth and keeps your team focused. And that's exactly the takeaway. Your workflow needs to scale with you.
So this brings us to our final lesson. Because as we promised, this isn't about TV. It's about how TV pressured everything. Our code, us, our tooling, our assumptions. And it taught us what really holds up at scale. And React Native is no longer just for mobile, right? We are building for scale. We've got multiple platforms, multiple target devices. So what holds up at scale? Well, Really, it's just about building for scale before you hit scale. Don't wait for scale to force your hand. Optimizing early means ending up with testing strategies and pipelines and tools that we showed you that don't grind your team to a halt when you grow.
Know your tools and your platforms. When you understand the quirks and limits of every platform that you target and choose your libraries and tools accordingly, it isn't just about React Native and Expo and web. It's about knowing what happens when your app runs in real world.
And as we said, automate as much as you can. Manual doesn't work at scale. We saw that. So make sure your tests, your CI, your metrics collected, everything that can save you time and help you catch issues early is automated.
And then, as a final point, just focus on the user. In the end, none of this matters if users have bad experience. Optimize for performance, stability, and accessibility, the stuff that real users care about.
So our last lesson is, as React Native developers, just always think about the bigger picture.
Thank you.
Thank you so much.
You can find us here.